This video covers Trig P.2, day 1. I'm going to divide the video up into 2 different days because the concept for this section is solving equations. And there are many different types of equations that we're going to be solving, and so that's why you can see that I wrote on here a variety of different equations. So let's start off with just your basic type of equation where you have variables on both sides and numbers on both sides. The goal obviously is to get the x's on one side, so I'll move these over here to try to keep that positive, and then the non-x's to the other side. So I'll move the 4 away by subtracting. We end up with 2x, that cancels, equals negative 12. Get rid of the 2 by dividing it, so we always do the opposite. We end up with negative 6 then. Sometimes you're going to have a little bit more complex problems than that example. This example is one that is a little bit more complex because I throw in fractions. So if you want to get rid of the fractions, and that's what I recommend that you do to solve this, what you have to do is look at all of the denominators, 5, 2, and 10, and figure out what number can you multiply them all by to make them go away. In other words, the least common multiple in this problem is a 10. So if you times everything by 10, because 5 goes into 10 evenly, 2 goes into 10 evenly, and 10 goes into 10 evenly, that's why I chose 10. I didn't choose 10 because it was the biggest number. I chose 10 because it was the least common multiple. Then you're going to use the distributive property and multiply each of these individually by 10. And what should happen is you would eliminate any of the fractions that you have. So when I do x divided by 5 times 10, 5 goes into 10 twice, so I do 2 times x. Minus 2 goes into 10 5 times, so I do 5 times x, so it would be minus 5x. Now here I'm just multiplying a whole number by a whole number, so I just get 30. Here I would do 10 goes into 10 once, and 1 times 3x is 3x. Now this problem looks very similar to this one. The only difference is you've got two like terms on one side, so if I combine those, 2 minus 5 is negative 3. Now move the x's over to the same side, so I'll get rid of these 3 by subtracting. Those cancel out, and I'll be left with x being negative 5. So anytime you've got fractions and you don't want to deal with the fractions, get rid of them by multiplying by the least common multiple. You can multiply by a number that's bigger than the least common multiple, and that would be okay too. So if you looked at this right away and said, oh, I know that all of these numbers divide evenly into 20, you can multiply by 20 as well. It's just then you're going to have to do a little bit of reducing at the end. Next concept here is just getting you to understand the difference between an identity and a conditional statement. A conditional statement is what we're normally used to seeing. Here's an example of a conditional statement. A conditional statement is where the left side does not equal the right side. So you can clearly see here 5x plus 4 is not the same as 3x minus 8. So the left does not equal the right. Okay? An identity, on the other hand, is when the left side equals the right side. So an example of that might be if I have like x squared minus 9 on one side of my equal sign, and on the other I have x plus 3 times x minus 3. I know this is an identity because if I was to take the time to factor this is the difference of 2 squares, I'd get the exact same thing. I'd get x plus 3 times x minus 3. So this is an example of an identity when the left side equals the right side. A much simpler identity than this is simply if you get something like this, 5 equals 5, or negative 2 equals negative 2, or 0 equals 0. When the left side equals the right, that's an identity. Conditional statements are what you deal with most of the time when you're solving equations, because when you go through and you solve it, you don't get the same thing on each side of the equal sign. So that's just a vocab reminder. Okay, the next type of equation that we're going to solve is when you have a fraction plus another fraction equals another fraction. So first thing you want to do is you want to try to combine these fractions if you can. And the way that you have to do that is you have to figure out what the greatest, or the common denominator is going to be. So if you're struggling to figure out what the common denominator is, multiply them together. So if I want to make this fraction have a common denominator of x minus 2 times x plus 3, what I need to do is multiply this by the x plus the 3. That's what it's missing. It has the x minus 2 portion already, it's missing this portion, so multiply it by that. Well, 1 times that doesn't change it. Okay, over here, if I wanted to put this in over one denominator, again, I have the x plus 3 portion of the denominator, I'm missing the x minus 2. So I'd have to multiply by x minus 2. So when I use the distributive property, it's going to be 3x minus 6. Now over here, what I'm going to do is I'm going to take the time to factor this so that I can see a relationship that forms here. If I factor this, what multiplies be negative 6, but adds to be 1, notice that that's negative 2 and a positive 3. This would be x minus 2 times x plus 3. So what's going to happen now when I do this is, if you've got the same denominators here, when we cross multiply, so when I cross multiply, x minus 2 times x plus 3 times, and I'll try to combine these together, that would make 4x minus 3. It's going to equal over here 4 times x minus 2 and x plus 3. Notice that what you have is you have an x minus 2 and an x plus 3, and an x minus 2 and an x plus 3. Those will actually end up canceling each other out, because what's going to happen when I do this is if I wanted to move these two over to this side, I would divide by them. And that would eliminate them from this side, and when I divide over here by the same quantity, x minus 2 and x plus 3, those cancel out as well, and I'm simply left with the idea of 4x minus 3 equals 4. And now this becomes really easy for me to solve. Add 3 and divide by 4. And what I like about solving equations is you always know for sure if you're correct. If you were to go through, take the time to go back and plug in to your original problem, a 7/4 for the x here and here, add these together, plug in a 7/4 for the x here and here, and then reduce this, you should be getting the same answer. Take the time to check these. It's not something that I need to see you write down, but it is something that I recommend that you do to make sure you are getting it correct. If we're continuing with the concept of factoring, when you're trying to solve an equation that has multiple variables in it, in this case x squareds and x's, you want to try to always make your x squared term be positive. So for this problem, if I want this to be positive, what I'm going to do is I'm going to move everything over to the other side of the problem. So I'm going to end up adding 2x squared, subtracting 5x, and then subtracting 3. And the reason I want to do this is because it makes factoring it pretty simple now. The rules for factoring when you have a coefficient here is you multiply to get these numbers, so 2 times negative 3 is negative 6, and you add to get negative 5. So it multiplies to be negative 6 but adds to be negative 5. That's a negative 6 and a positive 1. This method is called the box method because you have to draw a box. And in the box you will put the first term that you're factoring, which is the 2x to the second power, so the first term of the polynomial. The last term of the polynomial goes in the last box. And then in the two boxes you just came up with, you put these two numbers along with the variable, in this case an x. And now that you have the box, all you have to do is go across and down and find the greatest common factors. So going across here, I can take an x out of both. Going across here, I can take out a 3. But because this is negative, it's going to be a negative 3. If I go down now, between these two boxes, the greatest common factor is a 2x. And going down here, the greatest common factor is a 1. And because this box is positive, it's going to be a positive 1. So I'm able to factor this down to 2x plus 1 and x minus 3. If I'm not sure if I did that correct, if you FOIL it, you should get right back to this. Now the rules for solving once you have two things being multiplied together to equal 0 is you set them individually equal to 0. So this one I would have to subtract 1 and divide by 2, and I'm going to get a negative 1/2. This one I would just have to add 3, and I would get a positive 3 as my answer. So remember, when you have a coefficient in front of the x squared term, unlike over here when it was just an x squared, I could just multiply and figure out and make my parentheses right away. When you have that coefficient out in front, you have to use the box method. Last concept we're going to talk about in this section of the notes is getting rid of powers. In this case, if it's a squared, you take the square root. If it was a third power, you would take the third power. If it was a fourth, an exponent of 4, you take the fourth root. And what will happen is when you take the square root, the squared sign will cancel out, and you'll be left with what was ever underneath there. Now when you do this, if I want you to give me an exact value answer, you would leave this as the square root of 44, but remember that the square root has both a positive and a negative answer. So you'd want to put it as plus or minus the square root of 44. And I prefer exact value answers over decimals, so I'm going to leave this as the square root of 44, and then I'm just going to continue to solve, move everything away from the x. Now here, when I write this, since I can't subtract these because this is a rational and this is not, I'd write it as negative 7 plus or minus the square root of 44. Then I would divide. And actually what I'm just noticing is I can reduce this, and I probably should have done that before I subtracted the 7. So let me kind of go back here a minute. If I'm asking you to reduce the square root of 44, I know that it's the square root of 4 times the square root of 11. So I would really prefer that you wrote it as plus or minus 2 square roots of 11 instead of plus or minus 44. So I should have done that before I moved over the 7, but that's okay. You can always just go back and change it. So anytime you can pull out a perfect square out of a radical, please do that. So again, I said the perfect square was 4, so I said 4 times 11 makes 44. When I take the square root of 4, remember that's plus or minus 2, and you just drop down the square root of 11 with it. And then now when I try to subtract 7 here, I can't. And then the last step would be to divide by 4. So x would be equal to negative 7 plus or minus 2 square roots of 11 over 4. So a lot of concepts that we've talked about in this first section of notes. And there will be several other topics that we talk about in the second part or the second day of the notes. But the goal is still the same. Try to get the x by itself. Try to solve for the unknown variable. So we'll pick up with the second part of the notes on day 2.